and inequalities. Learning outcomes. At the end of the lesson, the learner is able to solve rational equation, inequalities, and solve problem involving rational equation and inequalities. Lesson outline. First, solving rational equation. Second, solving rational inequalities. Third, solving word problem involving rational equation or inequalities. To solve a rational equation, A. Eliminate determinators by multiplying each term of the equation by the at least common denominator. B. Note the eliminating denominator introduce extraneous solution. Check the solution of the transform equation with the original equation. Example 1. Solve for x2 over x negative 3 over 2x equals 1 over 2. Solution. The LCD of all denominators is 10 times and solve the resolving equation. 10 2 over x negative 10 times 3 over 2 times equals 10 times 1 over 5. 20.15 equals 2. 5 equals 2 times. 5 over 2 equals times. Example 2. Solve for x over x plus 2 negative 1 over 2 negative 2 equals 8 over x to the power of 2 negative 4. Solution. Factor each denominator in the rational expression. X over x plus 2 negative 1 over 2 negative 2 over equals 8 over x plus 2 times negative 2. Multiply the LCD to both sides of the equation to remove the denominator. X plus 2 over x negative 2 x over x plus 2 negative 1 over x negative 2 equals 8 over x plus 2 to x negative 2. X negative 2 minus x plus 2 equals 8. X to the power of 2 negative 3 plus negative 10 equals 0. Upon reaching the step, we can use strategies for solving polynomial equation. X to the power of 2 negative 3 times negative 10 equals 0. X plus 2 x negative 5 equals 0. And x plus 2 equals 0 or x negative 5 equals 0. And x equals 2 or x equals 5. Since x equals 0.2, make the original equation under 5. X equals 5 is the only solution. Paul, in an enter-barangay basketball liga, the team from Barangay Colate has won 12 out of 25 games, a winning percentage of 48%. How many games should try win a row to improve their win percentage to 60? Solution. Let X present the number of games that they need to win to raise their percentage to 60. The term has already won games out of their 25 plus X games. The equation is 12 plus X over 25 plus X equals 0.6. Multiply 25 plus x to both sides of the equation and solve the resulting equation. 12 plus x over 25 plus x equals 0.0. 12 plus x equals 25 plus x 0.6. 12 plus x equals 0.6. 25 plus 0.6 x 0.6 equals 5 negative 15 negative 12. 0.4 x equals 3. X equals 7.5. Therefore, Barangay Colite needs to win 8 games in a row to raise their winning percentage to 60. Example 4. Jeans walked 5 kilometers from his house to Quiapo to buy a new bike, which uses to return home. He averaged 10 kilometers faster on his bike than on foot. If his total trip took 1 hour and 20 minutes, what is his walking speed and kph? Use the formula V equals D over T. Solution. Using the formula V equals D over T, we derive the formula for the time T equals D over V. Let V be Jean's walking speed. Then V plus 10 is his speed on his new bike. Jean's walk time is S over V and his biking time is S over V plus 10. The equation now becomes S over V plus S over V plus 10 equals 4 over 3. Multiply both sides of the equation by the LCD and solving the resulting equation. 3V and V plus 10 and 5 over V plus 5 over V plus 10 minus 4 over 3 and 3V and V plus 10, 15V plus 10 plus 15V equals 4V V plus 10. 30 plus 150 equals 4V to the power of 2 plus 40V. 4V to the power of 2 plus 10V minus 150 equals 0. 2V to the power of 2 plus 5V minus 75 equals 0. 2V plus 15, negative 5 equals 0. V equals negative 15 over minus 15 over 2 or V equals 5. Rejecting the value V equals minus 15 over 2. We conclude the Jane's walking speed is 5 kph to solve rational inequalities. A. Write the inequality as a single rational expression on one side of the inequality symbol and zero on the other side. B. Determine over what intervals the irrational expression takes on positive and negative values. First, locate the x value for which the rational expression is 0 or undefined. Factoring the numerator and denominator is a useful strategy. Mark the numbers found in first on a numbered line. Use a shaded circle to indicate that the value is included in the solution set, and a hollow circle to indicate that the value is excluded. This number partition that number line to intervals. Third, select a test point within an interior of each interval. In second, the sign of the rational expression at this test point is also the sign of the rational expression at each interior point in the aforementioned interval. And fourth, summarize the intervals containing the solution. Warning: multiplying both sides of an inequality by a number requires that the sign positive or negative of the number is known. Since the sign of a variable is unknown, it is not valid to multiply both sides of an inequality by a variable. Sample 6. Solve the inequality 2 times over x plus 1 is greater than 1. Solution. A. Write the inequality as a single rational expression. 2 times over 6 x plus 1 negative 1 is greater than 0. 2 times minus x plus 1 over x plus 1 is greater than 0. X negative 1 over x plus 1 is greater than 0. C. Choose convenient test point in the interval determined by negative 1 and positive 1 to determine the sign of x negative 1 over x plus 1, and these intervals construct a table of the signs as shown below. And D, since we are looking for the intervals where the rational expression is positive or 0, we determine the solution to be the set. Plot this set on the number line. Example 8. A box with a square base is to have a volume of 8 cubic meters. Let x be the length of the side of the square base and h be the height of the box. What are the possible measurement of a side of the square base if the height should be longer than a side of the square base? Solution. The volume of rectangular box is the product of its width, length, and height. Since the base of the box is square, its width and length are equal. The variable x is the length of a side of the box, while h is its height. The equation relating h and x is 8 equals x over to the power of 2h. Expressing h in terms of x, we obtain h equals 8 over x to the power of 2. Since the height is greater than the width, h greater than x, and our inequality is 6 over x to the power of greater than x. A. To solve the inequality, we begin by writing and with it with 0 on one side. 8 over x to the power of 2 negative x greater than 0. 8 negative x to the power of 3 over x to the power of 2 greater than 0. 2 negative x to the power of 2 plus 2 times plus 4 over x to the power of 2 greater than 0. B. The rational expression will be 0 for x equals 2 and undefined for x equals 0. Plot on a number line. Use hollow circles since these values are not part of the solution. C. Construct a table of signs to determine the sign of the function in each interval determined by 0 and 2. Note that x over to the power of 2 plus x times plus 2 is positive for any real values of x. D. Since the rational expression is positive in interval 0 less than x less than 2, this is the solution set of the inequality. We are reject the interval x less than 0 given if the expression is positive here since we only consider positive values of x for the problem. Therefore, the height of the box should be less than 2 meters. Example 9. Dressmaker ordered several meters of red cloth from the vendor, but the vendor only had 4 meters of red cloth in stock. The vendor brought the remaining length of red cloth from a wholesaler for 1,120. He then sold those length of red cloth to the dressmaker along with the original 4 meter of cloth for a total of 1,800 if the vendor price per meter is at least 10,000 more than the wholesaler price per meter. How many additional meters of red cloth did the vendors pursue from the wholesaler? Solution. Let the variable x be the length of the additional cloth purchased by vendor from the wholesaler. The wholesaler price of red clothes per meter can be expressed 88 and 1020 over 8. The vendor's price of red clothes per meter can be expressed as 1600 over x plus 4. If the vendor sold his if the vendor sold his clothes to the dressmaker at a price that is at least 10 pesos more per meter, the inequality can be written as 1600 over x plus 4 greater than 1120 over x plus 10. A. To solve this inequality, we write with 0 on one side and simplify. The rational expression will be 0 for x equals 16 and x equals 28, and undefined for x equals 0 and x equals 4. Plot on a number line and use hollow circles since the value are not part of the solution set. The figure below is not drawn to scale. C. Construct a table of sign to determine the sign of the function in each interval determined by the values above. D. The rational expression is negative in the interval -4 less than x less than 0 and in the interval 16 less than x less than 28. However, since we are dealing with length of a cloth, we discard the interval where the length is negative. Also, the rational expression is 0 when x equals 16 and x equals 28. Therefore, the vendor brought the and sold additional length of red cloths from 16 -28 meters for the dressmaker. Solve example. First, solve for x plus 6 over x -4 equals 1 over 6 plus 1. Solution. The LCD is x -4 x plus 1 multiplying both sides of the equation by the LCD result in x plus 6 x -4 equals x -4 x to the power of 2 2x -24 equals x -4 x to the power of 2 plus x -20 equals 0 x plus 5 x -4 equals 0.
Therefore, x equals -5 or x equals 4. Since x equals 4 will make the original equation undefined. Second, solve for x 5x over x -1 less than 4. Solution. A. Rewrite the equation with 0 on one side. 5x over x -1 -4 less than 0. 5x over x -1 minus 4x -1 over x -1 less than 0. 5x -4x plus 4 over x -1 x plus 4 over x -1 less than 0. X plus 4 over x -1 less than 0. B. The rational expression will be 0 for x equals -4 and undefined for x equals 1. Plot the points on a number line and use hollow circles since these values are not part of the solution set. C. Construct a table of signs to determine the sign of the function in each interval determined to the values above. D. We are looking for the intervals where the function will be negative. The graph is shown below.
Solve for x 4 over 2x -1 greater than 1 over x plus 2. Solution. A. Rewrite the equation with 0 on one side. 4 over 2x -1 minus 1 negative over x plus 1 greater than 0. 4x plus 1 minus 2x negative 1 over 2x negative 1x plus 1 greater than 0. 4x plus 4 negative 2x plus 1 over 2x negative 1 2x plus 1 greater than 0. 2x plus 5 over 2x negative 1 plus 1 greater than 0. B. The rational expression will be 0 for x equals minus 2 over undefined for x equals 1 over 2 and x equal negative 1. Mark this on the number line where x equals minus is included while the others are not. Lesson 6 Supplementary Exercise. First, solve for x 2 times negative 1 over x plus 3 equals 5. 2. Solve for x to the power of 2 over x negative 3 equals x plus 2 over 2 plus negative 5. 3. Solve for x negative 1 over x plus 3 less than 0. 4. Solve for 1 over 6 greater than 1 over x negative 3. 5. Solve for x to the power of 2 minus x negative 30 over x negative 1 less than 0.
6. If a and b are real numbers such that a less than b, find the solution set of x minus a over b minus x less than 0. 7. You have 6 liters of a pineapple juice blend that has 50% pure pineapple juice. How many liters of pure pineapple juice needs to be added to make a juice blend that is 75% pineapple juice? 8. To ship traveling from Dumaguete to Cagayan de Oro differ in average speed by 10 kph. The slower ship takes 3 hours longer to travel a 240-kilometer route than for faster ship to travel a 200-kilometer route. Find the speed of the slower ship. Lesson 7. Representations of rational functions. Learning outcome. At the end of the lesson, the learners able to represent a rational function through its able of values, graphs, and equations, and solve problems involving rational functions. Lesson outline. First, table of values, graphs, and equation as representations of a rational function. Second, rational functions as representations of real-life situations.
Definition. A rational function is a function of the form where polynomial function and this is not the zero polynomial. The domain is all value of x where qxd is 0. Average speed or velocity can be computed by the formula. Consider 100-meter track used for foot race. The speed of a runner can be computed by taking time for him to run the track and applying it to the formula. Since the distance of is fixed at 100 meter. Example 1. Represent the speed of a runner as a function of the time it takes to run 100 meter in the track. Solution. Since the speed of a runner depends on the time it takes to run 100 meter, we can represent speed as a function of time. Let x represent the takes to run 100 meter, then the speed can be represented as a function x as follows. As x equals 100 over x. Conserve that it is similar to the structure to the formula S equals d over t, relating speed, distance, and time. Example 2. Continuing the scenario above, construct a table of values for the speed of a runner against different run times. Solution. A table of values can help us to determine the behavior of a function. As the variable x change, the current world record for the 100-meter dash in 9.58 seconds, set by Jamaican Usain Bolt in 2009, we state our table of value at 10 seconds. Let x be the runtime and Sx be the speed of the runner in meter per second, where Sx equals 100 over x. The table of value for runtime from 10 seconds to 20 seconds is as follows. From the table, we can observe that the speed decreases with me. We can use a graph to determine if the point on the function follow a smooth curve or a straight line. Some inequalities. Learning outcomes